Hey all, let's solve this famous Leetcode problem called burst balloons. Let's go through the problem and see how we can approach it and how we can optimize it better. Hmm. So let me reset the stopwatch and let's start looking at the problem. In balloons 0 to n minus 1, each balloon is painted with a number on it represented by nums. You need to burst all balloons. To burst a balloon, you need nums of I minus 1 star, nums of I star, nums of I plus 1 coins. Okay, if I minus 1 or I plus 1 go out of the bounds, then treat there is a balloon with 1 painted on it. Mm-hmm. Makes sense. Okay, what they are expecting maximum coins you can collect by bursting balloons wisely. Okay, uh, so let me frame this problem in a simple terms. So you are having n balloons and the balloons are filled with some coins inside it. So if you burst, sorry, mm, sorry, it does not contain coins. So balloon is painted with a number. So if you burst that balloon, you will get that many coins. Suppose you burst a balloon with number 9 on it, you get 9 coins. So not only getting coins, but to burst the tired balloon, you need to pay some coins. Uh, no, sorry. I'm tripping here. Mm-mm-mm. If you burst a balloon, you get nums of I minus 1 I and I plus 1 coins. Okay. Got it. Let me reframe it. You have n balloons, and each balloon has number printed on it. If you burst that balloon, you get nums of I minus 1 star nums of I star nums of I plus 1 coins. If I is equals to 0, consider nums of I minus 1 as 1 because I minus 1 goes out of bounds. And if I equals to n minus 1, consider I plus 1 as 1, nums of I plus 1 as 1. This is what they give. Now, what they are expecting from us, we need to return maximum number of coins we can collect. So, you need to burst balloons in an order such that you get maximum number of coins. So, before thinking of approach, let me explain with this example so that you can understand what they're expecting from us clearly. We have 3158 numbers printed on 4 balloons. Now, suppose if you burst third balloon first, how many coins you get? You get 1 star, 3 star, 1, right? You get 3, and then if you burst first balloon, you get 3 will be already gone, so you get 1 star, 5, 5. If you burst fifth balloon, 5 star, 8. 5 star 8 is 5 is a 40. Plus, if you burst eighth balloon, previous and next will be considered as 1 and 1, so it will be 8. Now in this sequence, if you go, how much is the maximum number of coins you get? Oh, sorry, not maximum, how many coins you get? 45, 48, 56, right? Now I'll burst in this way. First I'll burst balloon with number 1. How much coins do I get? 1 into 3 into 5, which is 15. Now then I'll burst a balloon with number 5. So now we just have 3, 5, 8. I burst balloon with 5. I'll get 3 into 5 into 8 coins. 5 8s are 40, 43 is a 120 coins. Now, what are the balloons left? 3 and 8. Which one should I burst first? I'll burst 3 first. So, I'll get 8 coins. If I burst last left is 8. So, at last I'll get 8 coins. Oh, sorry, it's here 3 star 8. It is 24 coins. Now, here the sum will be 167. This is the maximum we can get. You can try all the possibilities to check. So, yeah, while we are uh, doing this dry run, we are able to get with one idea. What it is, you can try to delete all the elements. You can try all the possibilities to delete an element and find max score. Now, what will be the complexity to find all the possibilities? So, deleting all the elements is like finding permutations of the given array. First which element, second which element, third which element, fourth which element. So, to do permutations, we need n factorial complexity. So, let's see constraints if that satisfies. So, n can be up to 300 and at least 1, and nums of I can be from 0 to 100. So here we don't need to worry about nums of I, since 100 is integer, so we don't need to worry much. Even if we multiply 100 300 times, in factorial, 100 100 100 100 100 100 100 thrice, it would be 10 power 6, 10 power 6 into n. 300 into 10 power 6 is 10 power 8 into 3. That's fine. That's not a big issue for us. Integer works for us since it is under 10 power 9. But the key thing is n. N can be up to 300. Now, if you do 300 factorial, it's a huge number. It's very huge. No? Uh, do you think? Yeah, it's huge. It does not satisfy the given constraints. No. How can we optimize it? Let me draw the pattern. So first, if you delete 3, remaining possibilities are all elements except 3. So it will be a binary tree. First you can delete 3, you can delete 1, you can delete 5, and you can delete 8. After deleting 3, you can same goes. You can delete 1, 5, 8. After deleting 1, you can delete 3, 5, and 8. Now after 3 and 1 is delete, we can delete 5 comma 8. Now if you see, you are deleting 3 1 5 here. This gives the same result till here, and here you are deleting 1 3 5. Hmm. If I delete 3, what will be there? 3 into 1 3, 1 into 3, 1 will give more. Okay, so this will not be the case. It will be 5 and 8 if I take 3. But here I get more, so no worries. 115. 3, if I take 3 first and 5 next. Okay, if I take uh 8 first and 3 next, it would be same. So here I can see a repetitive pattern. So at some stage, some sum of coins till current and remaining items stays same for multiple operations. Now, if sum till current and remaining items are same for two operations, do we need to perform it twice? No, we don't need to. So there is a repetitive task we can avoid. So to avoid, what we'll do, it's a simple pattern. We try to catch the result, and if uh, the current sum and the remaining items are in the catch, we just return it. We just return from the catch, or else we'll compute. So to check the result, what would be the complexity? So if you take current, all the possibilities are uh, 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 remaining possibilities will be there. Mm, let me think. If I take 3, possibilities are 158. Oh. Would be n star n, right? For each element, we need to we have n ways, and those n ways are overlapping. Yeah, would be of n square complexity. Now, what would be the space? Since we are catching them, the space would be of n square. Let me think whether I'm in right direction or not. Mm, 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 mm. I have an I try to delete each other element. Suppose 3 is there, possibilities are 158. Mm, let me think. I'm missing out something here. Mm, 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 mm. So we know what is the sum before, and we need to check all the things that we can bust next. So it would be left star right. Left can be till n, right can be till n. Would be of n square only, right? Mhm. Yeah, I think no. For space, why do we need n square? We need till I will capture the maximum possible. Let me think. Uh, Let me. We need to check towards the what is completed and remaining result. So for every state, we need to check all the elements towards left and right of n square and mm, 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 mm. Wait, I messed up here. For each state, we need to go left and right, and so it would be of n square into n, and space we need to maintain left and right, so it would be of n square. Yeah, sorry for the confusion here. Now we are able to identify this logic. So now as we know, like if we use memorization, it can it is computing every interval recursively, although we store in cache. So it takes some stack memory. To avoid that stack memory, we use bottom up dp. So we'll be having base conditions which satisfies the null situation, and then we derive the current condition, like we need elements towards left and right to compute the maximum sum. So suppose we are at k, the maximum we achieve is dp of left till k and dp of k to right. This is the intent behind doing uh, bo- behind the dp. So we need to find a way to make it bottom up dp. So now think in terms, if length is 1, what are the left and right? Left and right will be the 1. So we can achieve the value num itself. If length is 2, you can take any element first, you'll get the same result. So the result would be num1 star num2. This would be the result. Is that true? Let me verify it. If we have 2 and 3, if I delete 2 first, I'll get 2 star 3 6. And if I delete 3 next, okay. So we need to delete in a sorted order, right? Mm-mm-mm. Yeah. The key thing is, like, if uh, it is 2, there is no left element. So now we assign dp of left comma mm, right is 0. Yeah. Since there is no no balloon exists towards left and right, so we assign it 0 initially. Now as the length increases by 3, 4 or 5 so on, we need to get for the whole array we need to get the each every interval. For example, till for all the length I'll go for each left possible, for each right possible. I'm currently at k, so for every k, oh, not for every right is possible. Now k will be from moving from left to right. uh, I think I'm missing something here. S- mm, we depend upon uh, previous row to compute the current. We need left to right and sorry, left to k and k to right. Hmm. So yeah, let me revise it first. I need to wait. So I need to know uh, if I burst, uh, neighbors will keep changing. So I need to know which element should I burst first so that I'll get maximum count. Makes sense. Now, mm, 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 mm. So do I? If I want to know that when should I remove this element? If the element is towards the last, then all the elements towards left and right have already been removed with a maximum sum. Suppose there are A, B, C, X, P, Q, R elements, so on. If I need to remove X as the last element, now I need max score for A, B, C till X plus star X star max score from X plus 1 P, Q, R towards right. Yeah, this is the intent here. Left till K and K to right. Let me implement bottom up solution. Let me take an as length of nums. Sorry for the confusion, I got a bit messed up. So let me go ahead. No, we need a vector of vector. We need int is enough here for us since values can be up to 3 into 10 power 8 only. db of we need one extra two extra to store one and one towards 0 minus 1 and one towards n. So I take n plus 2 here and it should be also vector. Vector int of n plus 2 comma 0. Now I have vector. So now I need to insert one towards left and right. Nums dot insert nums dot begin comma 1. I have insert 1 towards end, pushback of 1. Yeah. Now it makes sense for me. Now If length is 0, it is already fixed, not possible. If its length is 1, we have only one way, which is num. For to get we should start from 2, length less than or equals to and plus 1, length plus. Now left can be till length. Now I need left, int left is 0, and left and length combined should be less than array, less than and plus 2, left plus, and from where should the k value be? For int k equals to left plus 1, k should be till left plus len, right? Yeah, let me take it as right here, int right left plus len. K can be till this point, k less than right k plus. Now have a middle state, left and right state, as we discussed. dp of left comma right would be max of until left plus towards right plus left element star middle element star right element. So let me explain clear. So let me consider current. Now we need to add max result towards left to k, and max result towards right k to right, and current result, which is nums of I minus 1 star nums of I star nums of I plus 1, right? Makes sense. Yeah, now we are having a maximum result at left comma right. At the end, if we reach n plus 1th index in the 0th row, it means we got maximum result uh, till we close the entire array. Got it? Now what is the complexity of this? So it would be the same O of n cube and O of n square. Now let me explain the code once. I got uh, messed up. So we are having dp of left comma right, which stores maximum possible sum if current element is taken as last. This is the intent behind my approach. Like if I want to take x, I should sum up maximum towards left and right. So dp of left comma right stores maximum sum if I want to take that element at last. So yeah, now it depends upon left to k. So maximum score from left to k and k to right. Here you can see the right part and the current score. If you want to remove x, this is the score which will add on to your final result. So like when I'm computing the intervals of uh, length, so I'm taking at least length 2 and up to n plus 1 length. So for each length, like as the length grows, the left index will be the starting and the right will be left plus length. So it will be like a subarray from left to right. So in that subarray, we are traversing k, so that we divide it into left and right partitions. So every possible last balloon is k. So k is the last balloon which we are removing from that subarray left to right. This is my intent. So yeah, this is like a 2D dynamic programming approach. I was bit confused in the memorization approach, like how do we store the states and what would be the memory complexity. But yeah, it's simple. So the key things you need to know, like uh, why we are taking from 2 to till n plus 1, and how we are dividing the subarray if we assume k as the final element. So why we take k as final element is because we are there is uncertainty to know that if we take this element now, do we get count or not. We need to do a recursive approach to find the maximum count. Whereas if we consider k as a final element, right, we already know maximum. If we take k as current final, in the left side of k there will be a previous k, in the right side there will be previous k. So you see there is a repetitive pattern going on. So you are uh, dividing subarrays and then finding out things. So I think it would be also a divide and conquer approach up along with dynamic programming. Maybe I'm unsure. Mm, 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 mm. Let me think once. Mm, 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 mm. We are checking left and right. Mm, 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 and doing it. So aren't we doing a greedy thing? Yeah. So yeah, this is a divide and conquer approach. So, but we are implementing it using dynamic programming. We are just dividing it k, and we are checking maximum possible towards left and right, and we are adding it. So it is we are dividing, we are solving left and right independently, and then we are combining. So it is not pure divide and conquer, because we are trying to overcome overlapping here instead of trying to be greedy enough uh, to think I need to divide it. The intent is more towards trying to memorize things and avoiding stack space. So this is like an interval DP you can think of. Yeah, it's a great pattern to learn. I think there are few good problems towards this. Let me look at. Yeah, this is also a good problem, and if feasible, I'll solve it tomorrow. Let's see. Bye.